My name is Robin Burke from the University of Colorado, and I'm happy to be chairing this session number 5 on content distribution. A wide variety of interesting talks today, and I'll let the speakers take it away.
Hi, thank you for being here. I'm Koustuv. I'm a PhD student at Georgia Tech, and today I'm going to present our work where we studied how the Russia-linked ad campaigns use the Facebook advertisement platform to micro-target their audience. First, I'd like to thank my co-authors, Filipe, Reza, Lucas, Johnnatan, Fabricio, Oana, Krishna, and Elisa. As many of us know, there was a lot of controversy surrounding the 2016 US presidential elections. One of the most prominent controversies, as reported, was the involvement of the Russian intelligence in influencing the political campaigns, which mostly also used the political campaigns through social media. In particular, one means that they used in influencing the political campaigns was social media-based advertising. But what was so special about this advertising was that they were targeted advertisements. That is, broadly speaking, they could control who were the audience of these ads. In May 2018, the House Democrats released a sample of over 3,500 ads that were run by the Russian Intelligence Research Agency, or the IRA. As I mentioned in the previous slide, these were targeted ads and used the Facebook advertisement platform to target their audience. A qualitative survey of these ads showed that they mostly belong to divisive or polarized content, such as those on race, crime, gun, or immigration. Before we proceed to the research questions, let us begin by understanding how exactly do these targeted advertising platforms function. They enable the advertisers to select the audience for their ads on social media websites such as Facebook, Twitter, Instagram, or YouTube. All of these websites gather detailed demographic, behavioral, and interest profiles of their users, and this information is then used on these advertising platforms to filter and select users in the targeted advertising. In fact, they may enable micro-targeting or when a small number of users are selected with very specific attributes. In the past, these platforms have also come under scrutiny owing to privacy and discrimination-related concerns. As we saw in the previous slide, these ads contain polarized and divisive content. With that in mind, we studied 3 research questions: how divisive is the content of these IRA-based ads, were the targeting of these ads effectively done, and what features of the Facebook advertisement platform were leveraged in targeting the audience of these ads. The entire IRA ads dataset consisted of 3,517 ads, and the temporal figure here demonstrates that these ad campaigns intensified near the US presidential election period. The average cost of these ads amounted at 34.5 USD, and the average number of views of 11,000, and the average number of clicks of 1,062. Let us talk about the click-through rate, or CTR, of these ads. CTR is a mechanism by which the effectiveness of an ad is measured. It is a measure of the percentage of clicks per total number of views or impressions of these ads. The average CTR of these IRA ads amounted at 10.8, which is extremely high compared to any other type of Facebook ads. For the purposes of our study, we define a subset of high-impact ads. These ads consist of a total of the top 10% ads in each category of cost, clicks, impressions, or CTR. We found 485 such ads that were posted before the presidential elections. Let us discuss about our first research question, where we were interested in understanding the divisiveness of these ads. We conducted US Census representative surveys using the SSI, or Survey Sampling International Survey Panel. We obtained 15 to 30 responses per ad from a total of about 3,000 unique respondents. We specifically conducted 3 surveys related to whether they would report or flag the content of the ad, whether they would approve or disapprove the content of the ad, and if they were able to identify any false claims present in these ads. Let us go over the survey on reporting. We specifically asked 2 questions. First, whether they would report or flag the content of the ads as shown. And second, if they would report, why did they consider the ad to be inappropriate? We borrowed the same options as used in the Facebook reporting interface. We found that about 75% of these ads were reported by at least 20% respondents. And among all the reasons, offensive content occurred the most. Participants were also given a free text box in case they wished to include reasons of inappropriateness, which included incites racism and creates divides in the society. We refer to the paper for more details, but summarily, we find that a majority of these ads showed the ideological divisiveness. Looking at these plots, as you can see, most of these ads elicited extremely opposite perceptions among the liberals versus the same among the conservatives. Here is a contrasting example. These ads target two different insightful topics. The ad on the left, which targets immigration in the country, mentions that immigrants are like parasites and we must get rid of them. This particular ad would have been reported by the liberals, whereas not by the conservatives. The ad on the right targets the topic of Muslims and that they are subject to Islamophobia. This ad would have been reported by the conservatives, but not by the liberals. Therefore, if the first ad is targeted only to the conservatives, they would probably never get reported. Whereas, if the second ad is only targeted to the liberals, they would again probably never get reported. So how well was the targeting of these ads done? Essentially, we compared the survey responses to these ads between the targeted audience and the representative sample of the US population. The green line here shows the responses among the targeted group, whereas the dotted line shows the responses among the non-targeted group. We find that had these ads not been targeted, the likelihood of being reported, being disapproved, or finding false claims in them would have been higher. We find that the IRA ads predominantly use the attribute-based targeting feature on the advertisement platform. These include demographic features such as gender, age, and location. These also included interest-based features such as their likes in newspapers or politics, or like their interest in the African American civil rights movement. We also found the presence of attribute suggestions which are done by the Facebook's ads platform. That is, if an advertiser is looking for an audience which has more liberal interests, Facebook would suggest 5 other pages that are dominated by the liberals. About 64% of these ads in our dataset use this feature of attribute suggestions. Let us now go over a few implications of our work. We characterized the Russia-linked ad campaigns on Facebook. We found that the ads to be socially divisive and 10 times more effective than a typical Facebook ad. These ads were based especially in race and political leaning. The targeted users of these ads were less likely to identify the inappropriateness present in them. This means that a Facebook advertisement platform can likely be abused to create social discord. Our findings supports call for greater transparency of content and targeting of political content on Facebook. We have hosted all these ads with the targeting and other sorts of information on this website. And with that, I would like to thank you all.
Hi, everyone. I'm back to the stage again. I'm Abhi. And now I'm going to talk about another work on analyzing users' truth perceptions of news stories and their implications for fact-checking. This is a joint work with my awesome colleagues and collaborators from Max Planck Institute, JCS, University of Maryland, and KAIST. If you like this work, all credit goes to me. If you do not like, blame them. Okay, as news consumption has moved from mass media to social media, we see a very rapid change in the whole news ecosystem. In mass media, news used to be produced by professional journalists. There were a limited number of news sources, and that enabled media watchdog groups to regularly monitor these different news outlets for any bias or inaccuracies in their reporting. However, in social media, news can be produced by any member of the crowd, number of potential news sources is very large, and that's why it's not possible to monitor all these news sources. So in essence, there is no accountability for the accuracy of presented information on social media. And as a byproduct of this, there has been proliferation of fake news. By fake news, we define the news which is verifiably false. Now, what does verifiability means? There are dedicated fact-checking organizations like Snopes, PolitiFact, factcheck.org, where there are expert fact-checkers who follow very principled methods like Pointer's Code of Principle to verify stories to be either true, mostly true, false, mostly false, etc. However, the problem is they cannot cover all possible news stories which flow around in social media. And the solution is to prioritize stories for fact-checking so that these expert fact-checkers can select them and fact-check them. The current prioritization strategy deployed in practice actually asks users to report stories which they perceive to be false. And then if stories which are reported as false by many users, prioritized for fact-checking. The question we ask in this work is this the best strategy? But the problem is, best according to what? Unless we know what's the objective of fact-checking exercise. Let's assume that one reasonable objective is that the platform may want to fact-check false news with higher probability than true news. So then the question becomes, does the strategy achieve this objective? In order to answer this, we need to know how users perceive the truthiness of different stories. Now, since we are all back from the coffee break and enough caffeine has been injected in your bloodstream, let me actually consider a few examples and let me take your opinion about how you would perceive the truthiness of these stories. So the first story claims that President Trump inherited a White House infested with cockroaches due to careless behavior of Barack Obama. Now, how many of you actually think that this is true? Great. Let me move on to the next story. Senator John McCain's vote against a skinny ripple healthcare proposal stopped attempts to repeal the Affordable Care Act. Now, how many of you think that this is actually a true claim? Okay, so most of you think that this is true. Now, I promise that I won't bother you much, but last story, and this claims that the national debt saw a surprising decline of $102 billion between January to July in 2017. Now again, how many of you think that this is true? Okay, one or two, okay, good. So most of you do not think that this is true. So just reiterating again, so for S1, most of you thought that this is false. S2, most of you thought that this is true. And S3, most of you thought that S3 is false. Let me actually show you what their actual truth value is. S1, as you correctly identified, is actually false. However, S2, although you thought that is true, it's actually false. And S3 is actually true. Let me add just one other story with the ground truth value, that President Donald Trump changed the Constitution to read citizens instead of persons, and this is actually mostly false. Now, as I did with you right now, we performed truth perception test on Amazon Mechanical Turk workers, where we asked the workers to very rapidly guess the truthiness of different claims as we presented to them. And that would actually give how users perceive the truthiness of different stories. And similar to as you reported, we also saw that the Amazon Mechanical Turk reported the similar truth levels or similar perceptions for the truth levels for these stories. So for example, the cockroach story, they all thought that it's false. Then for S4, they thought it's mostly false. But for S3, although this is actually a true story, they thought it to be false, and S2 being a false story, they thought it to be true. Now, if we were to rank by the current strategy of asking users to report stories, the priority ranking of the stories would be S1 followed by S4 followed by S3 and S2. That is when like we are going across the y-axis from down to top. However, the objective we set out there should actually order based on the x-axis from left to right, and then the ranking would be S2, S1, S4 and S3. And clearly the strategy does not achieve its objective. But more than that, it actually reveals two very systemic biases in users' truth perception. The first one is gullibility, where users perceive false stories to be true. And even we all have that kind of bias, as we just showed. And the second bias is cynicality, where users actually doubt even true stories to be false. Now the problem with the gullibility part is, if higher the gullibility to a false story, like if many people believe a false story to be true, then it's less likely that the story will be reported for fact-checking. And for cynicality, fact-checking true story would be wasteful if no action is taken to reassure the users that this is indeed true. So in summary, these are the limitations of current strategy, that there are systemic biases in users' truth perception. So relying on users' truth perception doesn't achieve the objective of fact-checking false news with higher probability than true news. The issue is this the only objective? We can come up with at least two other objectives. So depending on like how we observed how people actually perceive the truthiness of stories. So this one objective might be that the goal of fact-checking exercise should be to correct misperception of users. So then we would like to fact-check stories where users' perceived truth levels differ a lot from ground truth level. And the third objective may be that we would like to decrease the disagreement among the users. This is especially important, especially for very polarizing topics, where we found that if a particular story is against Democrats, most of Democratic-leaning workers, they reported it to be false. Whereas if a particular story is against Republicans, most of Republican-leaning workers reported that those stories are false. So maybe fact-check should try to decrease the disagreement by prioritizing stories where this disagreement is higher. The problem, however, is these objectives are incompatible. So even if we consider these 4 stories which I have shown you earlier, the rankings are very different if we follow like different objectives. When we considered even more stories, we saw very low correlation between the rankings, and there is virtually no overlap among the top stories. So the bottom line is, it's impossible to achieve the objective simultaneously while prioritizing stories, and the platform really needs to think about what objective it wants to satisfy while by all this like fact-checking exercise. To summarize, we examined how users perceive truth in news stories and how that impacts the fact-checking exercise. We introduced different objectives for fact-checking and show that they are incompatible, and essentially the platform needs to decide what objective they want to optimize for. The part which I didn't cover in this talk is, if the platform actually chooses one of the objectives, how can we provide practical implementations to prioritize stories to achieve the proposed objective? So these details can be found in the paper, and as always, like, I'm available for any questions you may have. Thank you.
Hi, thanks so much for coming. It's great to be here. Hi to everyone in the room and also everyone watching live. So today what I want to talk about is polarization that is being driven by personalization and ways that we can control it. And in this work, I just want to thank my co-authors, 2 excellent students, Sayash Kapoor and Farnood Salehi, and my co-author, Nishit Vishnoy. So the starting point is really this observation that there are these feedback loops that drive social technology. So there's a wealth of data about us collectively and about us individually that algorithms are using to model your likes and your behavior, and that is being used to decide what information is being presented to you. And this information is fundamentally different based on what the algorithms have learned, and can affect not just what you see, but also the opportunities that you are given, and indirectly your opinions and thoughts down the line. Now, this has been shown to become extremely evident in social technology in a variety of ways that can be seen to be problematic. Probably one of the ways in which is most evident is in social media. So as you see, the news feed of someone who is liberal versus someone who is conservative can be really dramatically different, and this is probably something you have observed just in your own life. As I said, though, it's not just about the information that you are consuming. It can also affect opportunities. So there's been more and more examples of online advertising where there's been significant biases in which types of ads, in particular for job opportunities and for housing, are being shown across gender or across race. So fundamentally, the opportunities being presented to you can differ quite dramatically. In addition, it has also been shown that the information that is presented to you, not just the content, but even the order in which you see it, can affect your thoughts and opinions, and can affect everything down to who you end up voting for. So clearly there are a lot of issues surrounding the polarization that can happen and that is being driven by these algorithms. Now, what all of these examples have in common is that really there is this big set of data or content out of which a much smaller subset is being selected to be presented to you. And this content that is being presented to you also has some important groups that it falls into. So you can think of this as being a group of left-leaning news versus right-leaning news. Now, what's happening in these examples is that the percentage of items from a particular group that is being shown to a particular consumer can be very different across the different groups, again, based on what the algorithm has learned about them. So if we think of this fundamental parameter, PI, as the percentage of items from a group that is being selected, again, what's happening is PI is much greater for some groups than for others. And so one way to think about how to control for this is to think of notions of group fairness, which really boil down to different functions of these PIs, where the more balanced they are across groups, the more fair in some sense it is. And there's many different notions of fairness, some of which you have seen. And of course, the million-dollar question is, which notion of fairness should we use in any particular context? So what we have done in this work is step away from that a little bit and not focus on one particular definition, but instead think of a more general framework approach. So instead of saying we should satisfy this particular definition of fairness across group content, we say, let's not worry about that. That is very context dependent. Your application might need a very different definition than mine. Instead, let's work just with these PIs, just with distribution for each group. What is its representative percentage? So what we take in as input as part of the formulation of our problem is going to be some upper and lower bounds on PI for each group. Now, what's nice about framing it in this way is that if you do happen to care about one particular type of fairness, is that you can translate your notion of fairness into upper and lower bound constraints. So it's kind of an extra step you have to go through in the middle, but we've shown that for many existing notions of fairness, and potentially for many more that could come up in the future, you can do this type of translation. Okay, so this is the general approach that we're going to take. We want to balance this content, but how concretely can we actually do that? So let's take one example of a personalized news feed. So the cartoon version is this. You again have this big set of content. And again, there's two different groups of content in this example, say red news and blue news. And you have your algorithm, which is generating this personalized news feed for you. Now, of course, what we said at the beginning is there's a fundamental feedback loop. This is not happening in isolation. As you like content or as you read content, this is being fed back into the algorithm, and that is what is being used to decide what to show you next. So the cartoon version of this, again, is that this algorithm underneath the hood just represents you in some high-dimensional space. And as you like some piece of content, it will update where it thinks you lie in this space, right? Now, as you do this more and more, say you happen to be liking or reading a lot of blue content, it will start showing you more and more blue content, which again means you're more and more likely to see it and read it in the future. So as you can see, what very quickly happens is that you end up driving people to an extreme, where we're showing you effectively all blue or all red content. So what is the cartoon version of our constraints? Now what we have done is, instead of allowing you to learn and personalize these PIs arbitrarily as much as you want, we're effectively just building a little fence that says you can personalize, but up to some extent. Now, one thing that I just want to point out here is that this notion still allows for personalization. These constraints don't have to occur across all dimensions of content. If what I care about is red and blue, I can constrain red and blue and leave the other dimensions unconstrained. So you're still allowing for a lot of personalization and a lot of the utility that you can derive from that, but constraining across key groups. Now, how do you actually determine this algorithm? What is happening on the technical side? There's many ways that one could potentially personalize or learn about people. And one very common way is via the concept of what's called a multi-arm bandit. So in a bandit, you have just different what are called arms, which in this case just represent different types of content. And fundamentally, what you want to do at every time step is maintain some probability distribution across these types of content. And every time step, you're going to show some piece of content. You are just populating this feed as someone scrolls down. And what you're measuring is what is called the reward, which is just a notion of how much the person liked that content. And you're going to use this to update your probability distribution from time step to time step. Now here, the fundamental goal in this problem is exactly to find exactly the type of content you like the most and show that to you all the time. So I won't go into the technical definition, but really you want to do exactly this. Show as much content that this person likes as possible. And there are many different algorithms to do this, which basically trade off exploration, trying to test new things that you might like that the algorithm doesn't know about, and exploitation, which is just showing you what you like. So how can we apply our fair notion here? What we think about in terms of this probability distribution is how much probability mass is placed on any one given group. And what the constraints in the setting are constraints on that probability mass. So the tighter constraints you have, the more balanced this probability mass has to be across the different groups. Now, instead of optimizing to just learn one type of content, we have to change the notion of what we're trying to learn here. And here what we want to learn is a probability distribution that still maximizes this reward. It maximizes how much you like what you're seeing, but subject to satisfying these constraints at every time step. And similarly, we have to change this notion of regret. But once we do that, the fundamental question is, can we design fast algorithms which we can actually use, actually implement in practice, that are still fair, that are still being balanced in the way that we want them to be? Now, once you frame it like this, this is a convex bandit optimization problem for which there is a lot of really excellent technical work. But that work lives in a much more general setting. Our constraints are actually very nice and very simple, and we can leverage the simplicity to get a nice, fast algorithm which forms the technical core of this work. Now, in terms of how it performs in practice, I am low on time, so I won't be able to walk you through some of the empirical results that we found, but one of the most important things that we observed was testing this out across many different data sets. What we saw is that by doing this balancing, we're actually not losing much in terms of utility. In terms of these counterfactual experiments, people still get to see content that they really like, and on top of that, we're still balancing it, so we're not losing much overall. And there are some small demos that you can play with, if you like, on our website for this paper and some other contexts where we've tried to apply this similar type of framework. So in summary, overall, what we've given is a general framework approach to control polarization. It's not tied to one specific type of fairness metric. It's flexible. It still lets you personalize, and just not across the key dimensions that you want to control. And what our evidence shows is that you can still extract significant utility using these methods while still controlling the polarization. Thank you.
So, hello everyone. My name is Dimitrios Bounturidis, and I'm from TU Delft. I'm a postdoc at TU Delft in the Netherlands. And today I'm going to talk about Siren, a simulation toolbox actually that we developed for understanding the effects of recommender systems in online news. So I'm pretty sure everyone is familiar with recommendations, right? So for Spotify, it's just a list of songs that you get every week based on your listening history. For Netflix, it's some movie suggestions based on your viewing history. And for news articles, if you're a subscriber to a news service, it's a list of articles that you get every week or frequently. And this is all good. People kind of enjoy these kind of recommendations, and content providers enjoy them as well because they make money out of them, apparently. But there are some issues. So some people suggest that recommendations kind of promote this imbalance between articles that are, or items that are already very popular compared to those that are least popular, and this imbalance gets even greater. And others suggest that if you keep giving the same items to a user specific to their history, then you kind of force them into a filter bubble, and eventually they don't explore the whole space available for them. They don't explore the variety of the service. Now, for news specifically, this is more complicated. The challenges are higher because those kind of concerns translate very easily to a lack of diversity in viewpoints, to limited voice, and eventually to kind of hindering democracy itself. So it's kind of it's very urgent right now to figure out if those concerns are realistic, and in order to do that, we argue that you need to have empirical control studies. In order to understand the recommender effects, you need to have controlled empirical studies. And that's easier said than done, of course. There are a lot of practical concerns. There's not a lot of data about news recommendations. And if you want to do A/B testing, there's so many different issues over there. But more interestingly, I think that online news have a very specific nature, which is, the problem is that you cannot take knowledge from the music and movies domain and kind of apply it directly to music, to online news. Now, in our perception, the online news universe has like three actors, kind of. You have the users, you have the content providers, and you have the recommendations. And all of these interact with each other in an online news environment, and eventually you have a reading behavior. So the way that content providers adjust the reading behavior is by what we call editorial curation, right? So they take an article and they put it in a prominent position on the web page, they adjust the fonts, adjust the colors, and they try to force users towards a certain direction. Recommendations also have a certain salience, right? Sometimes they appear in a box on your news website. Sometimes they pop up in your email, but there's a certain salience to that. You're not going to click on whatever you see on your email. And that results to the fact that users kind of distribute their reading between the recommended articles, the promoted articles, and the ones that they are actually seeking out. At the same time, users are not static, really. They have preferences that change over time. You might start on Monday being interested in politics, but on Friday you might be interested in entertainment. And all these requirements, what we try to do with Siren is we try to incorporate these requirements into a simulation framework, a simulation toolbox. So what Siren is, Siren is a simulation. It creates simulated users, simulated articles, recommendations, puts them all together, allows them to interact with each other for a number of iterations. And during that time, it tracks that behavior so that we can analyze them later. And I'm not going to go into all the details of how the system works. I'm going to give you like a kind of conceptual picture of how it works. So in Siren, users and articles are placed in a two-dimensional topic space, as you see in the picture over there. We've got sports, entertainment, technology, business, politics, all these regular topics in a news environment. And each article is represented as a point in that space. So this article here, it's more about entertainment and sports, so it's placed in that particular location. This user here, he's mostly interested in sports, tech, or business, so he's placed in that position, as you see over there. Now, at each iteration of the simulation, the reader decides to read a number of articles from the ones that are given to him. And the way that we do that is we say, okay, the user knows only a certain amount of articles, the ones that are next to his preferences, the ones that are promoted by the editors, and in this case, in this example, I assume that it's CNN, so they promote a lot about politics, and also articles from the recommendations. And at each iteration, the user decides to read one or five or whatever number of those articles. And after that is done, what we do is that we kind of adjust the user's preferences so he drifts into the topic space. He doesn't remain static in the topic space. Now, this is all good, but is there any benefits from using Siren? In our paper, what we try to do is we try to adjust the parameters of the simulation so that it agrees with studies of US news outlets and their users. We tried 5 different recommendation strategies from the My Media Lite toolkit, and we focused on long-tail diversity and unexpectedness. And in this presentation, I'm going to talk about long-tail diversity, really. So what you see here is long-tail diversity measured using the EPC metric by Vargas for 5 different algorithms throughout the simulation. I'm not going to go through all the algorithms. I think it's quite interesting to see that if you give to the users random articles as a content provider, you're going to end up with very low diversity. But surprisingly, if you use the item KNN approach, which suggests to you items of similar content to the user's history, you have a very high diversity. That's the blue line on the top. And it's interesting to see how is that possible, right? And here in this picture, what I try to show you is how users have drifted in the topical space that I presented earlier. And users are those black lines, and you can see the drift. And what you see happening is that, of course, users drift towards the topical centers, towards politics, business, and all this kind of stuff. But interestingly, you see that there are some clusters created, some kind of niche clusters. Some kind of maybe filter bubbles in a way you can call them, but these niche clusters allow the exploration of the article space in a very efficient way. So conclusions, there are not a lot of conclusions, to be honest. It would be very nice to go check our GitHub page. We have a very nice GUI that you can use. It's very intuitive. We have also very nice help document over there. So this is our team, and thank you very much.
All right, then we've got microphones on either side. I see people coming up. So let's have your questions for the speakers.
Hey, Aloni Cohen. I had a question about the modeling in Elisa's talk, the polarization.
Yes.
You said that the constraints you were looking at were lower and upper bounds on these PIs, where the PI was per group, and that was a general constraint. I don't see how I can use that class of constraints to, for example, encode statistical parity if I don't also know what I want the ratio to be? Like, I don't know how to say I want P1 equals P2, but I don't care what number they equal. Is it?
Right.
Am I missing something?
Yeah, so there's basically you have to wrap it in another little optimization problem where if you have the fairness constraint and the target's 0.8 or 0.9 or whatever it is you want, then there are a range of Li and Uis that if you set them like that will satisfy your target. So then you still have to do kind of a little outer layer of optimization, but it's usually something like linear search for most of these class of fairness metrics to determine exactly what the optimal constraints are. Thanks.
Hi there, I'm Luke Rodriguez from UW. I have a question for Abhi. So I was curious in your talk how, which was very interesting, how you were coming to conclusions about flagging what we might want to be fact-checking. And I'm curious, one, if there are other interventions that we might pursue other than fact-checking or other ways of conveying information to the users about these stories, and how those different types of interventions that we might do might affect your process of flagging these. Thanks.
I think that is a very interesting question. And one approach which people take, like instead of really fact-checking and then saying that, okay, this is fact-checked to be true or false, is actually sometimes present diverse perspective on some particular event or topic. So for example, Wall Street Journal actually has a system called red feed, blue feed, where it's on the same topic, they show tweets coming from like well-known Republican sources and well-known Democratic sources. And in fact, like we did some work last year where it's a combination of both, which we call the purple feed system, like where instead of focusing more like extremely right-leaning versus extremely left-leaning sources, we try to see that if something is in between and we can like resurface some of the information which is present in these extreme sources, but still maybe the messaging is like more polite and more moderate in these other sources. So that is one other option like which we tried. But in general, I think from more practical point of view, I would suggest that this fact-checking and reliance on it will continue to be more used, at least sometime in future.
Hi, I'm Erica Green. I'm from a startup called Canopy, and I had a question about for Elisa about the polarization, controlling polarization. So I was just a really interesting talk, by the way. I was struck by your categorization of news as left-leaning news versus right-leaning news, and I used to work at a media company on the tech side and at a newspaper, and I think that's a really dangerous categorization. Actually, I think that that's a categorization that has that further polarizes people, and I don't think that's true. I think that there's some complexity there, right? Newspapers or media companies will have editorial pages. The people on the editorial pages may have a point of view, but there are journalistic standards that any decent news reporting organization holds themselves to, and they report facts and they report. This is a long, big argument, right? But the New York Times, I don't believe, is a left-leaning organization. I don't know if you were suggesting that, but I just think it's a very simplistic. I see this. And sorry to harp on this for your work, I've heard this and seen this in a lot of other work, and I think that we should really understand the media landscape a little bit better and not put things into left-leaning buckets and right-leaning buckets, and that Google News shouldn't be trying to optimize left-leaning and right-leaning news. They should optimize quality and truth. And so I just was curious if you've thought about that and what your response was.
Yeah, thanks so much for bringing this up. I think that is such an important thing to be aware of, and this was very admittedly a characterization for illustrative purposes to kind of have these two categories. But you're absolutely right, the reality is much more complicated, and it's harder to explain in a 10-minute talk, but the methods are really a lot more nuanced in that these groups, first of all, they don't have to be disjoint. You can have overlaps. You can have intersectional groups, so the methods work for a much more nuanced landscape, where you can also think of these groups as being defined as effectively by topic models, where we have some, of course, there's the quality, which we're trying to optimize, and then maybe there's, let's say, some 5% of the I mean, you still have to quantify it a little bit, but it doesn't have to be yes or no,
Yeah.
and it doesn't have to be this or that.
Yeah. Okay. Interesting. Thank you.
Thank
I will
you.
read the paper.
Hi, I'm Joshua Loftus from NYU, and I don't quite understand why polarization is thought to be a bad thing. So I'm wondering if those of you who have worked with the data in this can help me understand that. Thanks.
Okay. Sure, I'll talk again. Yeah, that's a complicated question. I don't think it is necessarily always a bad thing. I think that in some cases, what evidence from other work is showing is that it can have down the line effects on people. Basically, you're not reflecting even what someone thinks, you're reflecting an extreme of what they think. So in a sense, even if your goal is just accuracy, it is not representing accuracy. So that would be one argument for why you're not as one-dimensional as a polarized feed makes you seem to be.
All right, I'm going to let the internet have its say here. So this is a question over here on the microtargeting talk. The question is, should ad platforms include a random element to ensure ads are shown to some users outside their target audience? Would that help mitigate the problem?
Yeah, that's a good question. Actually, there's an interesting ethical dimension to it. First of all, like, should the Facebook advertising platform claim and do what they are doing? So, like, if the advertisers they are claiming that they will help the advertisers target or control their audience, then they have to do that. But that said, I mean, one of the contributions of our work that is like, and also recently Facebook posted that they want to inspect all the content of the ads that are posted. So one thing that could be done is that micro-targeted ads, they can be prioritized based on that, like ads which have very specific audience, they can be prioritized and their content can be checked before they are posted. That is one way to like minimize this sort of misinformation or inappropriate ads getting to like audiences which are more likely to believe in them. And I mean, this is the difference between targeted advertising versus traditional advertising, where like traditional advertisement could go to a bigger set of audience and there are more chances to get it reported or finding the inappropriateness.
Hi, I'm Shanjiang from Northeastern. I have a question for the fact-checking paper from Abhi, I think.
Yeah.
Okay, so in your research, you give the claims made on Twitter on Mechanical Turk and let the Mechanical Turk workers to label a spectrum from true to false. But I think a lot of the claims made on Twitter is a little bit hard for people to intuitively judge whether it's true or false. So if it's a real user, they might do some research on Google and try to find some kind of evidence. But on a platform such as Mechanical Turk, I think people always have the incentive to finish the job as fast as possible because they can earn the money from the platform. So which makes it likely, so people just give you a random answer in order just to get the money from the platform. So I'm just kind of curious if you're taking some sort of measures to see whether people are really doing the task or they are sort of giving the random answers so we just get paid.
This is a very nice point, and I would just maybe the point which you are making corroborates what we also tried to prove, that actually asking users to report false stories is a very bad idea. So, and the other point was that maybe in Mechanical Turk people want to finish tasks quickly so that they can be paid, and at least for our task we wanted that, like we wanted to, it's like kind of gut checking, like what people think about this particular claim, whether it's true, false, and something in between. And another thing is that at least for the implementation purpose, we don't expect like every news story on Facebook or Twitter to be sent to say Amazon Mechanical Turk workers to get their responses. I think maybe Facebook or Twitter platform can actually run this small surveys from their own user base and ask them that if they can very quickly identify some stories to be either false or true, and depending on that they can now deploy some algorithms to prioritize stories for fact checking. So it's not like completely reliant on the Mechanical Turk system, but one like takeaway is that if you rely on them, then it may not be what you would want to achieve.
All right, we are out of time for this session, but don't go away. The next session on law and society is coming right up. But first, let's thank these speakers.